We're here to finish up section 2.1 with a look at the slopes of secant lines and tangent lines. So let's start out by looking at the slope of a secant line. All right, recall from the last video that a secant line was a line that joins 2 points on the curve. So we need to come up with the slope of a line between 2 points. Okay, so let's say we have 2 points, whether you call them A and B or P and Q, they would have coordinates of x1, y1, and x2, y2. Okay, so think back to algebra. And we will use our good old slope equation from back in the day. Slope M is the rise over run. You may have learned it that way. Rise or change in the y divided by run or change in the x. Okay. Well, the change in our y values would be y2 minus y1 over x2 minus x1. But let's say instead of calling those y, that we used some function notation. Since we have these 2 points on the curve of some function, we'll call that function f of x. So instead of calling this y1, we just say it's f of x1. And y2 is f of x2. Okay, so then our slope equation becomes f of x2 minus f of x1 over x2 minus x1. And this should look pretty familiar from something we just saw a little earlier in this section. All right, let's go up and see where that was. Hey, check this thing out. The thing in the box here. Our average rate of change formula looks pretty much identical to the secant slope formula. It's just in this average rate of change, we used the variable t instead of x, but hey, it's just a variable. We can call it what we like. So these are actually the same formula. So that tells us that the slope of a secant line represents an average rate of change. All right. Slope of a secant line provides an average rate of change for the function. Okay, so that is really good to know. Now, in order to help us look a little bit at a tangent line, we are going to do something kind of funny with our secant slope formula here. And so bear with me for just a moment. We are going to take that denominator, the x2 minus x1, and we're going to do a little something with that here. We are going to define the distance between our two x values, so between x1 and x2, to be another little variable called h. Okay, so we could say if you take x2 minus x1, that's the difference or distance between those two x values, that would equal h. Okay, and then if we take that little equation and solve for x2, we add x1 to both sides, and x2 would equal x1 plus h. Okay, so that might seem kind of like, okay, why are we doing this? I'll see in just a second. With our new definitions here, we're going to rewrite our slope formula in terms of just x1, a single point, and this new little variable h. So this is still an average rate of change. This is still the slope of a secant line, but we could also say that the slope m is f of, instead of x2 now, we're going to write in x1 plus h. So f of x1 plus h minus f of x1. We're going to leave that one alone. And then in the denominator, x2 minus x1, that's the thing that we just said we were going to call h. So in the denominator now, it just says h. Okay, so that is another version of the secant slope formula, or an average rate of change. All right. Now, how that's going to help us is with our tangent line, because remember that a tangent line doesn't involve two different points on the curve. That was a big assumption that we made right here in setting up our secant slope, was that we had two different points to look at. A tangent line, remember, is the limiting case of all those secants, and we are only looking at a single point on the curve when we have a tangent line. So we can't make an equation or a slope formula that involves two different points. We've only got the one. So that's why we've chosen now to rewrite this slope formula, because that only involves one x value, x1. Okay, so for a tangent line, we're just going to write the general idea here. We are going to let the distance h approach 0 in this slope formula. M equals f of x1 plus h minus f of x1 over h. Okay, so that distance h, remember, that's the difference between our two x values, x1 and x2. So as our 2 points get closer and closer together, remember, this would be like your x1, this would be like your x2, the distance between those we're calling h. That distance gets smaller and smaller until it basically becomes 0, no distance at all between the 2 points. And that's where we have our tangent line. Okay, so that is how we are going to calculate a tangent line slope. We'll do that in the next video.